Hey everybody, Mr. Rubo here. Today we're going to talk about real zeros of polynomials. So there's going to be a few things we're going to review today. The first is synthetic division. So if I have a polynomial and I want to see, hey, is it divisible by another polynomial? So I'm going to do some synthetic division. Now, remember, there's a few rules with synthetic division. You can only do it if what you're dividing by is a linear term. So there's no squared here, so I can do it. There's no cube, no all to the first power, so I can do it. And so we're going to go ahead and do the little setup. So I know there's different ways of writing it. I like to do the big L. So negative 2 goes on the outside, and that comes from this, because this is the factor. The 0 is negative 2, though. You always put the 0 out here, and then you put the coefficients of your x in the constant term. Now, something you have to be careful with is, are you missing any constants? So we have 3 from x to the 4th. That's the highest. X to the 3rd would be next, but we don't have that, so we have to put a 0 in. Don't forget about the 0. People do that all the time, and it messes them up. You don't always need one, but when you do, you have to have it. So then negative 2, positive 15, and then negative 8. All right. So remember, the steps are the same throughout. So the first one is the only different one is you just bring this one down. So it's 3 down here. You then multiply, so 3 times negative 2 is negative 6, and then you add. So 0 plus negative 6 is negative 6. Do the multiplication again. Negative 2 times negative 6 is positive 12. Add, you get 10. Do it again. It's the same process over and over again, so that's really nice as long as you know the process. This would be negative 20, right? Negative 2 times 10. Add it together, you get negative 5, and then multiply, you get 10, negative 8, plus 10 is 2. So now we have no more to do, so we're done. We just have to actually figure out what this means in terms of our answer. So this first term, I always like to start from the right side instead of the left. It doesn't really matter though. So if you're starting from the right, this is always your remainder. Okay, we hope this is 0, but it's not. So it just means that x plus 2 isn't one of our factors, right? Then it's our constant, then it's our x, then it's our x squared, then it would be our x cubed, and so on and so forth until we're done. If you wanted to start on the left side, you just take whatever the degree was and you go down 1. So our final answer for this is 3x cubed minus 6x squared plus 10x minus 5, remainder of 2. So if you want to, you can write it as remainder on top and divisor on the bottom. But you don't have to. You could also just say remainder of 2. Okay. So if you were asked to find the remainder, synthetic division works. However, there is a better way of doing that, and that is using this theorem called remainder theorem. It's a crazy name. So if you want to just find the remainder, and instead of having to do all this synthetic division or long division, depending on what we're doing, if you just want to see what the remainder is, all you have to do is take this 0, so x plus 2, so we'll do the exact same example, and you substitute it in. Okay, so in other words, what the remainder theorem tells us is when you substitute in the value, so let's say x1, it's going to equal the remainder. So let's just see if that's what happens. So here, let's substitute in negative 2 into this function. So we're going to get 3 times negative 2 to the 4th minus 2 to the negative 2 squared plus 15 times negative 2 minus 8. So let's simplify this. So that would be what? 16. 16 times 3 is 48. That's 4 minus 8 minus 30 minus 8. So now 40 minus 30 is 10. 10 minus 8 is 2. And look at that, we got the same answer. So if the question just asks for the remainder, just substitute in the number, and it will tell you the remainder. Okay. Now, if it wants you specifically to see, is it a factor though, then we just do the same thing. We can use remainder theorem and this other thing called factor theorem, which is really what you should already know, is basically if your remainder is 0, it's a factor, right? So in other words, if we kind of combine these two together, if you substitute in something and you get a remainder of 0, then x1 is a factor. Okay? So that makes it so we don't have to do synthetic division every time. Now the problem is, what happened, like how do we figure out these numbers to substitute in? Obviously this one I gave you x plus 2. Well, guess what? There's another nice little theorem that's called potential rational roots theorem. Ooh, that was ugly. Yeah, whatever, theorem. I'm going to erase that. So we're going to do PRR for short. So basically what this tells us to do is if we have a polynomial. So I'm just going to take a random one that I've got that's actually in your notes. We got this guy. So this will tell us the potential rational roots. It doesn't tell us that they are the rational roots, but it will tell us all potential ones. So we'll come up with a list of ones, and then we can use factor theorem to see if they actually are factors or not. All right. So the way potential rational roots theorem works is we call all the factors of this term, of the constant term, factors are equal to p. Then all the factors of the coefficient, so here 1, we're going to call q. So if we list out all the p's, oops, let me change colors. All the p's, we would have plus or minus 1, plus or minus 3, and that's it. Okay. Then for the q's, we would have plus or minus 1. Okay. Now, the potential rational roots theorem tells us that all the potential rational roots, so all the possible rational roots, are going to be these p's over the q's. So you're going to go through all the different combinations. Now, you really don't have to worry about the plus or minus signs because, yeah, positive 1 over positive 1 is positive, but then a negative over a positive and a negative, like, you're going to get the plus or minus every time. So you just put a plus or minus in front of all of your answers. So you're going to do p over q. So 1 over 1, which is 1. 3 over 1, which is 3. So that means that your potential rational roots here are plus or minus 1, plus or minus 3. Now, if there was like a plus or minus 2 for q, then you would have like 1/2 and then 3/2. Okay? And so what these are telling us is that these 4 roots, 1, -1, 3, and -3, those are all the potential rational roots. There are no other rational roots that could happen. There could be irrational ones or imaginary ones, but these are the only rational ones that will happen. So to test these, to see if they work, substitute in each one. So you'll have to do 4 substitutions and see if you get 0. If you get 0, that's an answer. If you don't get 0, it's not an answer. Okay, so I'm going to leave that for you. But yeah, you literally just substitute in 1, you get 0, it's an answer. It's a root. If you don't, go to the next one. Do -1. Substitute it in, simplify, you get 0, that's a root. Do 3 and do -3. Depending on the question, if they're asking for just 1, once you find one you can stop, but if they don't, you would want to substitute in until you found all the possible ones, or all the ones that are, not the possible, these are the possible. Okay. If the question just asks for the possible ones, though, you're actually done. Okay. So hopefully this helped, and have a good day.